This is a question from artificial intelligence. In a feed-forward neural network with the following specification. The input layer has 4 neurons and hidden layer has 3 neurons and output layer has 2 neurons, and it uses a sigmoid activation function. And the given input values are 0.5, 0.8, 0.2 and 0.6, and the initial weights for the connection are also given, that is input to hidden layer and hidden layer to output. And the question is, what is the output of the output layer when we give the input values are passed through the neural network? So first of all, there are two major concepts to understand here. First one is a feed forward neural network. Feed forward neural network. So ideally, a feed forward neural network is a neural network that is characterized by the direction of flow of information between its layers. So it is a unidirectional flow of information. That is feed forward. It moves the information from input to input through hidden nodes, if any, to output node. This is how basically feed forward neural network works. So that is one concept. Now the second concept is the activation function. The activation function of a node in a neural network is a function which calculates the output of that node based on the input and their weight. So activation function decides the output of a node based on weighted summation of its input value. Weighted summation of its input. And here the activation function is given as a sigmoid activation function. A sigmoid activation function is characterized by the formula 1 by 1 plus e raised to minus x, where x will be the weighted summation of the input value. And based on the information given, the neural network will look like this. That is, we are having 4 neural networks, 4 nodes as the input, then 3 nodes as the hidden layers, then 2 nodes as the output. And the connections across them will be or like this. From this node it will be to all the hidden nodes, then from this node it will be to all the hidden nodes, then from the other node it will be to all the nodes. Similarly, from this node it will be to across all the nodes. This same concept applies in the next phase also, that is from this node to here and here, from the next node to both these nodes, then from this node to both the nodes, and this will be the output. So this is input layer, this is hidden layer, and this is the output layer. This will be the basic structure. Now let's try to solve it. So we'll solve it one by one. So the first case is given as input layer to hidden nodes. So we are having 4 input nodes and 3 hidden nodes. So basically the connection will be, let's write the input values. It will be 0.5, this is 0.8, this is 0.2, and this is 0.6. Now we are having 3 hidden nodes. First, this is characterized by h1, this is h2, and this is h3. So basically the value of h1 will be calculated as the weighted sum. So that means to this node it will be 0.5, and the weights of first one is given like this: 0.1, 0.3, 0.5, 0.2. So this will be 0.5 into the weight for this will be 0.1. Then from this node it will be 0.3. From this node it will be 0.5, and from this node it will be 0.2. This will be the value of h1. So let's try to calculate it. H1 can be calculated as 0.1 into 0.5 plus 0.3 into 0.8 plus 0.5 into 0.2 plus 0.2 into 0.6. This will be the value of h1. So this will be equal to 0.51. This particular value of h1 will be 0.51. Similarly, for other nodes also, this same format applies. So h2 can be calculated as the weight for will be for the second neuron will be these weights, that is 0.5 into 0.2, 0.5 into 0.2 plus 0.4 into 0.8 plus 0.6 into 0.2 plus 0.2 into 0.6. So this will be equal to 0.66. 0.66. Actually, this will not be the final output value. This will be passed to the 0.51 will not be the final output that is produced by H1. This will be passed through the sigma node activation function. So H1 is 0.51, H2 is 0.66. Let's note it down somewhere. So H1 is 0.51, H2 is 0.66. Now let's calculate the value of H3. H3 also can be calculated in this similar way. So let's try to calculate the value of H3. H3 is equal to basically 0.3 into 0.5, 0.3 into 0.5 plus 0.5 into 0.8 plus 0.7 into 0.2 plus 0.2, 0.2 into 0.6. This will be equal to 0.81, 0.81. So H3 is equal to 0.81. Now let's calculate the activation function's value. So activation function A1 means for H1, the value will be 1 by 1 plus e raised to minus x, and x will be here 0.51. So A1 will be 1 by 1 plus e raised to minus 0.51. This will be equal to 0.624, 0.624. This will be the final value of H1, 0.624. Then A2 is calculated as 1 by 1 plus 1 by 1 plus e raised to minus 0.66. This is equal to 0.658, 0.658, 0.658. Then A3 is calculated as 1 by 1 plus e raised to minus 0.81, which is equal to 0.692, 0.692. So 0.692. These are the basically the values of hidden layers. Now this will be passed on to the final output layer. So let's try to take that case also. So now we are having this basic structure: 4 input nodes, 3 hidden nodes, and 2 output nodes. Now all the connections till this and have been finalized. We are able to calculate it. Now the value of H1 is 0.51, sorry, 0.624, 0.624, 0.624. Then this value is 0.658. This value is 0.692, 0.692. These are the three values. So the basic connection will be like this. We have calculated till this part. Now we'll try to track the connections from here to this node. These two, and these two. So let's try to solve it. So hidden layer to hidden layer to final output layer. So that the output, this can be denoted as O1, this is O2. So O1 can be calculated as, the weights are already mentioned here. So O1 can be calculated as 0.624 into 0.4 plus 0.658 into 0.1 plus 0.692 into 0.3. This will be calculated as 0.523, and O2 will be calculated as 0.5 into 0.624 plus 0.2 into 0.658 plus 0.4 into 0.692. So this will be giving a value of 0.72. Now let's calculate the final result. Y1b 1 by 1 plus e raised to minus x, 1 by 1 plus e raised to minus 0.523. This will be equal to 0.62, and y2 will be equal to 1 by 1 plus e raised to minus 0.72, which will be equal to 0.68. These are the final output values, 0.62 and 0.68. These are the final two output values. Let's see if that is there in options. From the options we can see 0.62 as well as 0.68. So based on the options, option 1 is the right choice.